Hi students, we are moving to the third unit of the subject signals and systems. From this unit onwards, we are going to see signals from a different point of view. That is the frequency spectrum of the signals. If we look from the frequency domain, how the signals will look like. All these things are possible because of an amazing finding by a scientist called Fourier. So his full name is John Baptist Joseph Fourier. He was an active politician at the time of Napoleon Bonaparte. Even he was a ruler of a small city in Egypt at the time of Napoleon Bonaparte. And he has also contributed so much of things to the scientific community, including biology, mathematics, and engineering. Actually, this amazing Fourier series he found when we were studying about the heat distribution in solids. Now, to understand this concept, let us think about Newton's prism experiment. Before Newton's prism experiment, people have seen rainbows on the sky, but they thought that this is an astonishing, amazing phenomena which happened in the sky, and there will be some supernatural powers behind this rainbow. But Newton, through his prism experiment, he passed the sunlight through the prism and he found that it is split into different colors. That is what Vibgyor we are studying from small class onwards. Violet, indigo, blue, green, yellow, orange, red. Right? Before Newton, nobody was knowing about this fact. That is, the light, the white light is made up of different colors, different spectrum of colors. Right? So his experiment paved a way to look the white light from a different perspective. Now we know that the white light is not pure white light, it is a spectrum of light. It has different frequencies. This white light is composed of different frequencies, and if you can split the white light into different frequencies, you can see the violet in a particular frequency, indigo in another frequency, red in another frequency, like that. That was an amazing finding by Newton. Right? So that made us to look light from a different perspective. Similarly, this idea of Fourier, that is Fourier transform and Fourier series, help the mathematicians and engineers to look signals from a different perspective. That is the frequency domain perspective. Actually, the history of Fourier series is very beautiful. So Fourier was very much interested in contributing something to the scientific world. So he had this amazing finding that any arbitrary function or any arbitrary signal can be expressed as a sum of different sinusoids of different frequencies or harmonically related sinusoid. That was his contribution, right? So he found this basic idea when he was studying about the distribution of heat in solids. And after this finding, he had written a paper and he had to appear before famous mathematicians so that he can get approval for his paper to be published in a journal. So these famous mathematicians were Lagrange, Laplace, Monge, and Lacroix. The three mathematicians were in favor of Fourier, but still they criticized that your mathematics is not perfect, you have to make it a little more rigorous in a mathematical point of view. But Lagrange was against this idea of Fourier, and because of his huge criticism on his work, Fourier was unable to publish his paper in the Journal of the French Academy, and he was very sad about this. And after 15 years of different disappointments and hard work, he was able to publish his work in Journal by the French Academy. But in the beginning, he had not get enough attention or the approval from the scientific community for his findings, but towards the end of his life, everybody appreciated his work, and even the scientist Maxwell said that this Fourier series and Fourier transform is a poem of mathematics. So he was very much interested in this Fourier series and Fourier transform, and he appreciated the ideas of Fourier series and Fourier transform. Now, how Fourier series and Fourier transform help engineers? For example, I am recording this video in this place, right? This is my cabin. Now, assume that there is some motor or some machine is running somewhere at a distance, right? I cannot turn off that machine from this side, or I cannot ask the people to turn off the machine because some urgent work is going on. I am also in an urgency to record this video. What I can do if I have only the time domain look of the signal? I look into the signal and I can see my speech along with the noise, but I cannot identify where is the noise of the machine located in the signal. I cannot find out where is the noise location. I cannot remove it from the time domain perspective. But if I can look from the frequency domain perspective, it is very easy for me now. What I can do? I can simply see the spectrum of the signal, which shows the different frequency components in the audio recorded, which include my sound and the machine sound. And if I can able to distinguish the frequency of my sound from the machine, assume that the machine is having a high frequency, so the spectrum will show a high frequency peak at a particular frequency which is equal to the sound frequency of the machine. I can do some kind of filtering operations to remove this unwanted noise from my audio signal, right? So it has so many amazing applications in communication, digital signal processing, digital image processing, and in the entire scientific world of engineering and mathematics. Even though Fourier was sad and disappointed when he published this paper, his finding of Fourier series and Fourier transform transformed the engineering world, which have contributed so much to the multimedia and the internet, and especially a fastest algorithm called fast Fourier transform, which computes this Fourier series coefficients, helped us to do so much of signal processing applications which we do on a daily basis on audio signals, images and videos, right? So this is an interesting and important topic, so please pay attention to this video series. Here we are mainly studying about continuous time Fourier series, right? So how can we express a continuous time periodic signal as a sum of sinusoids or complex exponentials? That is what we are trying to see in this video. After watching this video series, you will be able to analyze the continuous time Fourier series of a given periodic signal and synthesize a given signal using the continuous time Fourier series.